Yes. So in the last class we had seen milling problem, CNC milling. So now we'll go to the other problem on CNC milling only. Right. Yes. Okay. So this is the diagram that is given. So problem number 3. Copy down this diagram. Copy down the diagram. Problem number 3 from CNC milling. So this value is 50 over here, not 60 or 80, it is 50. Yeah. Yeah, is it over?
Yes, sir.
Right. Okay. So take the same thing over here. So for this first, we are supposed to draw the blank, okay, which we generally assume for our programming purpose that it is going to be from okay. So now this is at where we have this particular corner. We'll take it as number 1, 2, 3 is here. So each one of them, so this corner number 1 is at a distance of 25 mm from the left hand side edge as well as from the bottom edge. Okay, so we'll keep the same thing from all the 4 sides. Okay, so this is corner number 1, 2 here. We have 3. Okay, and 4 here, 5, 6, 7, 8, 9 over here, and 10. Okay, totally 10 corners, and finally the program should end over here where we started, that is at point number 1. Okay, right. Okay, and apart from this, we have through two drilling hole that has to be made for a diameter of 16 mm. Okay, so where it is at 30 mm distance from the edges and at a height of 30 mm from the horizontal also, right? Okay, so for this, first let us write the uh, coordinates. Yes, yeah, yes. For point number 1, uh, it is 25 from the horizontal as well as 25 mm from the vertical edge. So first point 25 comma 25. Okay, second point, the height is 50. Okay, so change is only in the y direction. X direction, it is the same distance, so 25. Y direction 50 plus 25, 75. Okay, right. And then point number 3, here the distance is totally 50, but before that there's a radius of 8 mm. Okay, so 50 minus 8 just before that 8 mm. So 42, 42 plus, okay, this 25 will give us 67. Okay, and the height is the same 50 mm plus 25, so 75 mm. That is with respect to point number 3. Okay. Next, point number 4, the end of the radius. Okay. So here it is going to be x distance is going to be up to 50 plus this 25. So it's going to be 75. Point number 4, x value, and y value 50 plus 8. It would have gone for a height of 50 mm till here plus 8 mm, right? So 58 plus this 25 becomes 83, right? So that's the coordinate for point number 4. Yeah, point number 5 over here. Okay, so it is going to be for a total height of 100 mm. Okay, so plus okay, so here x value it is going to be 50 plus 25, 75. Y value, the total height of the diagram is 100 plus allowance 25. Okay, so 125 for point number 5. Then point number 6. Okay, the x value is going to be from here. If you look at this particular dimension, okay, from here it is going to be 100 mm plus this 25. Okay, so x point number 6, x value 125, y value is going to be also 125 because 100 plus 25. Okay, then point number 7 over here. Okay, point number 7, x value is 125, y value is going to be, this height is 50 plus this 8 mm, 58 plus 25. Okay, so all these things put together, point number 7, y value will be 83. Okay, nothing but same as point number 4 only. They both lie at the same height. Okay, right. Then point number 8. Okay, it's going to be, x value is going to be 133. That is 100 mm plus 8 mm, 108 plus this 25. Right. So it's going to be 133. Then y value will be 75. 50 plus 25. Then point number 9 over here. Okay, the value is going to be total distance from end to end. It is given here 150 plus 25. So 175 is the x value. Y value is going to be 75. And finally, point number 10. Okay, point number 10 is going to be, second. So point number 10 is 175 is the x value. Okay, and 25 is the height. So here for point number 4, it has to be R8. Let us not forget that. And here, when we count from here, point number 7 to 8. So here it will be R8 once again. So total length is 150 plus 50 mm. So we can have here billet size to be 200 mm in length. Width is 100 plus 50 on either side, 25 on either side, so 150. And Z thickness, will take it as 40 mm. Yes. And then we have point number 7 and 8. Sorry, not point number 7 and 8, the point number 11 and 12, where we have to mark the center of this circle and find the values of this. Okay, for these two holes, that has to be done. So where this one will be, or a distance of x value will be 55, and height will be 30 plus 25, again 55 only. And this one will be 150 minus, it's not 150, yeah, 150 minus 30, 120. So x value will be 120 plus 25, 145, and y value will be 55. Right. Let's copy down the coordinates. Let's see the program. Is it over? Yeah, over. Completed. Copied down the diagram. I mean the coordinates. Okay, so let's see the program. Okay. Okay, so yes, we'll start with the percentage symbol and then the program number, capital O, double zero three or 0003. Okay, then N01, G21, G94, and G90, G40 is not required, it's okay. Anyway, school compensation cancelled. Okay, yes, next line G28, X0, Y0, Z0. Okay, then uh, then the next line N03, T0101, then uh, and the next line is going to be, sorry, here it is M06, T01, then uh, N04, G43, H01, then the next one N05, next line M03, spindle start 1500 RPM, coolant on, M08, then G00. Here what we can do is that um, instead of coming up to X0, Y0, Z0, it can be only for, you can get it directly over here. This is not required. G00, X25, Y25, Z5. So it is going to lie directly above point number 1. Okay, that is corner number 1. Okay, yes. Next, G01, X minus 15. Okay, so we are going to do the end milling for up to minus 15 mm at a feed rate of 40 mm per minute. Okay, then here it's going to be next line G01. Okay, X25, Y75, that is point number 2, coordinates for point number 2. Then G01 coordinates for point number 3, X67, Y75. Then from there, it is going to take anti-clockwise direction. The tool has to move G03, X75, Y83, R8, and during turning, we generally reduce the tool speed. Okay, right? And then from there, G01, X value is going to be the same, so we can write only the whichever the coordinates value is going to change. So y is going to be 125, and f we can get it back to 40 since it's going to do end milling in a straight line. Then G01, y value is going to be the same as 125 only. So x value is going to change. X is going to become 125. Then next point G01 x 125 y 83. Then next line G03. So here it is going to make again anti-clockwise direction. The tool is going to move. So G03 x 133 y 75 r 8, okay, and f 30. Then we are going to have G01 x 175, y value is going to be at 75 only, okay. So if you write it, it's okay. If you don't write it, it is going to take the previous y value only. Then G01 y 25, x value is going to remain the same as x 175 only. Then next line x G01 x 25 y 25, right? So that is reaching back to its original, I mean to point number 1 where we started. Then G00 x 5, okay. Then stop the spindle M05, stop the coolant. The next line send it to home position. Then go for M06, tool change. T0202. Okay. Then next line is going to be N22 G43 H02. Okay. So this tool number 2 is going to be for the drilling tool. Okay. We have to drill 2 holes. Okay. Then here we are going to have get it to point number for to make the first hole whose coordinate is x55, y value will be should also be 55 only. Y value is, this height is 30 plus 25, 55. 50, this 55. Z value at 3 or 5, no problem. Then start the spindle, sorry, tool change, start the spindle M03. Okay. So the next line over here will be N24, spindle start, okay. And then, yes, so at this particular coordinate, the tool has to be inserted, that is the tool has to be moving vertically downwards until it becomes z is equal to minus 10, okay, right? And then get it out G00, okay, take the tool out, so G00Z5, okay, and then the next line N27, move the tool to the other coordinate where we have to make another hole, okay, so G00x145 and y will be y will be 55, yeah, that. Next line, now we have to drill the hole, move the tool vertically downwards, so G01 Z minus 10, okay. Then next line, G00, get the tool out, and then next line, spindle stop, coolant off, M05, M09, okay, and then send the tool back to its home position, G28, X0, Y0, Z0, and then finally M30, that is the program. Yes, copy down the program, then we'll see the video. Okay, copy down this program. Yes, copy down this program. Yeah, completed. We'll copy the program.
Yes, sir.
You have written the program, all of you.
Yes, sir.
Right. So let's see the simulation. Okay. Yes. Okay. So we'll go to CNC milling. Already the program will be typed onto the, you have to type the program onto notepad, save that file, import it over here. Okay. Then, so next go to define blank. Okay. So in x-axis, We want 200, y-axis 150, and blank thickness, okay, 30 or 40. Anyway, in the question, if they're not mentioned these details, you can choose it appropriately, especially the thickness of the blank, right? And also they wouldn't have, if they are not mentioned the depth of cut to do end milling and to drill a hole. If it is not there, then you can assume it suitably. So yes, next we'll go to I mean, to select a machine. Yes, select one machine. Then before we do it, the errors, it's sometimes easy for us. It's better that we choose the tools first, and then go for checking for any errors in the program. So one is going to be so one is going to be the tool for um, doing the end milling operation, tool number one. The next one is going to be for twist drill, okay, to do hole, okay. But actually, before these things, we have always milling should start with face milling operations, which we have already done for the previous two problems. So it has not been included. But actually, when you execute it in the test or exam, even face milling operation codes should also be there. Okay. Right. We'll check the error. No errors. Okay. So the program is right. Now we'll go to simulate it. So yes. So directly we're going to start with end milling. So we have got it over here at x25, y25, and z is at a height of 5 or 10. Now insert it. Then here the end milling starts. Right, so end of it. So wherever we have started, the tool, the end milling tool should reach back there only, and then take it out uh, of the of the workpiece. Send it to home position. Yes, get the drilling tool. Okay. Yes, after that, take it out. Send it to home position. Right. So we'll see the same thing in line mode in a different view. You can see we can trace the lines where the tool is moving according to the program. And now we are going to have the drilling tool in the first place where we want to make one hole. Then take it out, go to the next position, do the drilling, return back to its home position. Okay, yeah. So we have different options to see the same, to see the how the simulation has been done from different views. Okay. Yes. So this is problem number 3 on milling. Okay. Right. Okay. Yes, answer your attendance. Niharika. Niharika has not joined. She has not logged in. Okay. Nihar.
Yes, sir.
Nihar.
Yes, sir.
Okay. Nikhil. Nikhilar. Nikhilar is not there. Nilesh. Nilesh.
So present, sir.
Okay. Nirab.
Yes, sir.
Prajwal R. Patel.
Present, sir.
Okay. Just a second. Okay. Then Prince.
Present, sir.
Okay. Prajwal S. Bhatt has not joined. Rishabh Pandey.
Present, sir.
Rohan.
Present, sir.
Roshan.
Sir.
Okay. Suman Sagar.
Yes, sir.
Sagar GB.
Present, sir.
Sagar
Sagar Das
Mathur.
Mathur, sir. Present,
Yeah.
sir.
Okay. Sanjay. Sanjay.
Present, sir.
Okay. Saranaya. Saranaya has not come. Right. Sheikh Manan.
Present, sir.
Okay. Shobit.
Present, sir.
Yeah. Siddharth Shankar. Siddharth Shankar. Then Siddharth Sridhar. Siddharth Sridhar.
Sir, Siddharth Shankar put it in a chat box, sir.
Okay. Siddharth Sridhar has not come. Okay. Subramanya.
Present, sir.
Okay. Sumuk. Sumuk.
Sir, Sumuk is also put it in chat, sir.
Okay. Then Tirmana Shetty Rohan.
Yes, sir.
Okay. All right.